Hello students, this is Chemical Kinetics Part 2 and here we will discuss rate expression and rate constant along with the characteristics of rate constants. Okay, so let's take a chemical equation. A plus BB gives rise to CC plus DD where A, B are reactants and C and D are products. A, B, C, D are stoichiometric coefficients of capital A, capital B, capital C, capital D respectively. So here the rate is directly proportional to concentration of reactants. So here reactant is A and B. So rate is proportional to concentration of A to the power x into concentration of B to the power y, where x and y are experimentally determined, that cannot be determined theoretically. And we cannot say that x is equal to A, y is equal to B. It may be same, it may be different. That is, x and y may or may not be equal to stoichiometric coefficients. So rate is equal to, if we will remove this proportionality sign, then we have to multiply a constant. That constant is here taken as k. So rate is equal to k concentration of A to the power x into concentration of B to the power y. We know what is rate. Rate from the previous discussion, rate is equal to minus the concentration of R divided by dt. That is equal to k concentration of A to the power x into concentration of B to the power y. This is called differential rate equation. This equation is called differential rate equation. And here k is called proportionality constant or rate constant. Now let's discuss rate law. What is rate law? It is the expression in which the reaction rate is given in terms of molar concentrations of reactants, with each term raised to some power which may or may not be same as stoichiometric coefficient of reacting species in a balanced chemical equation. So what does it mean? So let's take an example, it will be easier to understand. So 2NO plus O2 gives rise to 2NO2. That means what? Nitric oxide reacts with oxygen to form nitrogen dioxide. If we will take the rate here, the rate will be equal to how much? K into concentration of NO to the power 2 into concentration of oxygen. So this is practically determined. This is not theoretically determined. We cannot say that these two represent this, that the stoichiometric coefficient of nitric oxide, and this one represents here. It is not determined like that. So how it is determined? This is the differential rate equation also. Okay, so how it is determined? How it is determined experimentally? Let's know about that. So when this experiment is conducted practically, you will see, suppose we are going to increase the concentration of nitric oxide twice. That means we doubled the concentration of nitric oxide and we kept constant the concentration of oxygen. That is, oxygen concentration is kept constant. Then what did we observe? We observed that the reaction rate increased by factor 4. So we made the concentration of nitric oxide double. And what did we observe? We observed the reaction rate became 4 times. That means what is the relation between 2 and 4? It is 2 square is equal to 4. Similarly, once again when we will conduct the experiment once again, then what did we observe? In the second step, what did we do? We kept constant the concentration of NO and we doubled the concentration of oxygen. Then what did we observe? We observed that the rate of the reaction is increased by a factor 2. So what does it mean? So here we have made double what? The concentration of oxygen. So what did we observe? We observed that the reaction rate increased by 2 times. That means what? We doubled it, we got also double. So the relation between 2 and 2 is 2 to the power 1. So from this, like this, we have to determine what? This rate equation. It is determined like this experimentally, but not theoretically. Got it clear? Let's see some other examples. Some other examples are here presented in front of you. You can see it carefully. You watch it carefully. Try to understand it. Suppose here we are taking what? CHCl3, that is chloroform. So you are observing chloroform reacts with chlorine to form what? Carbon tetrachloride with HCl. So here the rate of the reaction is equal to K into concentration of CHCl3 into concentration of chlorine to the power what? Half. You cannot say like that. If here it is 1, so we will take here. It is practically determined. So the rate equation is like this. Next you will observe what is hydrolysis of ester. It is here ethyl acetate is here. So when ethyl acetate undergoes hydrolysis, it forms acetic acid along with ethyl alcohol. So here the rate is equal to K into concentration of ethyl acetate to the power 1 into concentration of H2O to the power 0. It is found that this equation is independent of concentration of water, that is to the power 0. So it is independent of concentration of water. Okay. So next we will see what is definition of rate constant. What is the definition of rate constant, or that is also known as specific reaction rate? So let's take the previous example, that is 2NO plus O2 gives rise to 2NO2. So what is the rate expression? Rate expression, it was discussed earlier, that is K into concentration of NO to the power 2 into concentration of O2. So if we will make concentration of NO is equal to 1, concentration of oxygen is equal to 1, then it will be 1 square is equal to 1. This is also 1. So finally what we will get? Rate is equal to K. So if concentration of all the reacting species gets unity, then rate becomes equal to rate constant. Clear? So what will be the statement of this specific reaction rate or rate constant? The statement is specific reaction rate is defined as the rate of a chemical reaction when the concentration of each reactant is unity. Clear? So what are the characteristics of rate constant? It is a measure of rate of reaction. Greater is the value of rate constant, greater is the rate of a reaction. That means if K value increases, the rate of reaction increases. Next is, it is temperature dependent. That means K has a particular value at a particular temperature. If temperature changes, then rate constant value also changes. You know, if the temperature increases by 10 degrees Celsius, the rate of the chemical reaction almost doubles. So next is, the value of K does not depend upon the concentration of the reactant. It does not depend upon the concentration of the reactant, but it is dependent on temperature. Clear? Unit of rate constant depends on what? Order of a chemical reaction. So what is order of a reaction? That we will discuss in what? Next video. Okay. Thank you for watching.